So your control variables. Number 1, water kept at a constant temperature. You didn't measure the temperature, Flatzoid, so that's an assumption. Number 2, water level stays constant. Let's see. If we look at this green thing over here, we can see the water level before the orange is added. Oh, now half of the green thing is missing. Now the orange has been added. Oh, now we can see more of the green thing. So yeah, your water level didn't stay constant, did it, Flatzoid?
This is the orange. Let's submerge it in the water.
So 10:04 submerged.
As you can see, it is floating. This is a bit counterintuitive, as you would think this is the structure where it has the most mass. So therefore it would be needing to attract to the Earth, which would be the larger mass. Maybe it could be the air bubbles in the pores that's holding this up. Let's clean.
So you gave it till 10:28. So 24 seconds.
The air bubbles off. See, we're cleaning it off, making sure that there is no air bubbles in, just as the
So let's say 32.
control says. Nope, it's still seeming to float. So definitely not the air bubbles holding the orange up. What do you think will happen when we remove the peel, which is removing?
Which you gave to 51, so you gave 19 seconds that time.
The mass. See, I'm cutting the peel off and we're going to peel it off so it has less mass. So less mass based on the gravity postulation would mean that the orange should now float easier or be even less submerged. Let's see what's going to happen when I've taken the peel off, which is now making it less mass, and sticking it back into the water. Just waiting for me to pull all the extra mass off. There we go, looks nice and clean, you see. Let's drop it in.
So 37.
Oh boy, we already see an issue. It seems to be lower. There's an issue here. Less mass means it's gone lower. Maybe
To 44. So 7 seconds.
some air bubbles still in. Let's just clean it off again to give it control.
So 46.
Okay, got rid of all the air bubbles inside, which would give it buoyancy.
I see you didn't ignore buoyancy there, but you do ignore buoyancy and what the buoyancy formula is.
Now we've taken that air bubbles out. It seems to have sunk. So this doesn't show a great result for gravity, does it? This shows strictly that it's the displacement of the object to the medium. This has been shown now.
Well, that's paused, isn't it? So 46 to 11. So about 25 seconds.
Relative density disequilibrium.
Relative density disequilibrium. How do you know that, Flatzoid? You didn't measure the density of the medium or the density of the object before or after taking off the peel or anything. You didn't measure the density of anything. You didn't measure anything. Just assuming and confirming your confirmation bias.
Then we move on.
Okay, so he says, analyse the results. After doing the experiment, we were able to observe the mass is not the cause for the acceleration between the two masses, but the ratio of displacement between them. So the ratio of displacement, not the ratio of the densities. You didn't even measure displacement either, Flats. You didn't measure anything, displacement or density of anything. So no, that's your conclusion that you've jumped to. This has shown that the ratio between an object and the medium rely solely on one another, and the relationship of direction between the two is dependent on the displacement relationship. Again, you didn't measure that, did you? This shows that if the medium is able to support the object based on the displacement, it will direct the object to the relative density equilibrium point and thus sit at a rest until acted upon by a force. Again, you didn't measure anything, did you, Flats? The uneven distribution of the object and the medium is what causes the movement, and thus it entirely has proven to manifest its own fictitious force. This determination keeps with Newton's second law of motion. Also, fictitious forces can cause objects to accelerate now then, Flats. You're debunking yourself all over again in all ways. On the do your research part, it says, if the medium is able to support the object's displacement, it will accelerate upwards until it finds its relative equilibrium state. Why would it need supporting, Flatzoid? If the medium is able to support the object's displacement, it will accelerate upwards until it finds its relative equilibrium state. Why would it need supporting, Flatzoid? Well, that may be your prediction, Flatzoid, but it's wrong, isn't it? Because buoyancy is a thing, you know? And buoyancy is rho GV, where rho is the density of the medium, G is 9.81 meters per second squared, and V is the volume. So, yeah, your prediction is totally a straw man, and you're not including buoyancy in this, which, by the way, the globe and all scientists claim that buoyancy is the reason things go up, not just because it's less mass. On another one of your control variables, you say remove air pockets on the exterior of the orange. What about air pockets within the orange peel, or underneath the orange peel, Flatzoid, like a life jacket? So you didn't take away the air that would be underneath the orange peel, trapped within the orange peel, did you? Or underneath the orange peel, as a layer surrounding the orange and the orange peel? No, you didn't. So again, this is just a confirmation and shows that you don't actually know what you're doing when it comes to experimentation. You never once measured the mass to show that it was more mass or less mass. You never once measured the mass to see whether the orange took on any water when you took the orange peel off and absorbed water, making it more dense, making it have more mass. Not once did you do any of that. This is a biased experiment, Flatzoid, and it shows that you don't know how to actually do an experiment. So this is the orange dry, 39 grams. And this is the orange wet, 42 grams. It gained mass by being wet too.
Okay, got rid of all the air bubbles inside, which would give it buoyancy.
The buoyancy formula is rho GV. So why haven't you measured and calculated the buoyancy, Flatzoid? So we know that buoyancy is rho GV. So did the density of the water change? Probably not. Did G change? No. Did the volume change? Yes, the volume changed. You changed the volume of the object. You changed the volume displaced. Therefore, you changed the buoyancy force. Now weight, W equals mg, you also changed m. So you also changed the weight. So the amount of buoyancy force needed for the weight to go up would have also changed. See, these are the variables that you're not taking into consideration, Flats, because all you want to do is strawman and misunderstand. Try taking into account the variables, try actually measuring the things, and then actually try repeating the experiment. Until then, all you have is confirmation bias and really bad experimentation.
This is an orange.
Well, at least you got something right, Flats. Now, Flatzoid, can you tell me why this orange is flipping around, please? What is causing this orange to flip around? It's also nice to know that you now know what mass is. So no more what is mass BS, right?
Oops, I did it again.